Okay, global functions. JavaScript provides 9 global functions that we'll talk about. The object contains all the global variables in the script, all the user-defined functions in the script, all the built-in global functions listed on the following slide. You do not need to use the global object directly. JavaScript uses it for you, so it's assumed. So you get a couple of is infinite takes a numeric argument and returns true if the value of the argument is not NaN, number, positive identity, infinity, or negative infinity. Values that are not numbers or numbers outside the range that JavaScript supports. So basically, this tells you if it returns true, then it's not really a usable number, period. If it returns false, then it's a usable number. Is NaN takes a numeric value and determines whether it's a number or not. So that's useful when you get some input to know whether it's a number or not. Parse float, we've seen that already. It takes a floating point number out of a string. And depending, it starts with, if the first character is not a number to begin with, then the value is 0. Otherwise, it will parse until it hits something that it cannot convert to float. So ABC 12345 is 0, but 123.45 ABC is 123.45 is the value. ParseInt does a similar thing, but it does it with integers. Again, it takes, starting with the first character, as long as it's a number, it will convert until it hits a non-number or the end of the string. Recursion is a function that calls itself either directly or indirectly through another function. A recursive function knows how to solve only the simplest case or base case. If the function is called with a base case, it returns a result. If a function is called with a more complex problem, it divides the problem into 2 conceptual pieces: a piece that the function knows how to process, the base case, and a simpler or smaller version of the original problem. So this is kind of like, recursion can be used to do almost anything that a loop can do. And the base case is essentially the same thing as the sentinel value. Right? It's the sentinel value. The function invokes calls a fresh copy of itself to go to work on a smaller problem. This invocation keeps on going until it hits the base case. The recursion step executes while the original call to the function is still open. It's not finished executing. For recursion eventually to terminate, each time the function calls itself with a simpler version of the original problem, the sequence of smaller and smaller problems must converge on the base case, or must eventually hit the sentinel value. It's the same thing. We'll see that in a moment. At that point, the function recognizes the base case, returns a result to the previous copy of the function, and a sequence of returns ensues up the line until the original function call eventually returns. So it keeps on calling. If it calls itself 10 times, then there needs to be 10 return statements. So the first one is 5. It's looking to see if is the number 5. Then it calls it again, 4, 3, 2, 1. And eventually gets 1. So 1 would actually be the base case. It's looking for the prime number. To illustrate how this would work, it's going to call a function called factorial, this loop. If we look at factorial, we'll see that factorial says if the number passed in is less than or equal to 1, this is the base case or the sentinel value, return number times factorial minus 1. And eventually you get something that works its way down to the base case. And we know that 10 factorial is whatever that is. Large number. Really large number. Omitting the base case results in infinite recursion, just like forgetting the sentinel value results in infinite loop. If your browser determines that there's an infinite recursion going on, just like with an infinite loop, it will allow you to stop it. Firefox simply stops it as soon as it detects the problem. Let's look at the example first, and then we'll talk about how we can do one or the other. recursion. Let's see if it's in list of the source now. Okay. Function factorial. So this gives you an idea of what's happening here. Cole's factorial. And the factorial basically says if the number is less than or equal to 1, return 1, else return number times factorial number minus 1. So it subtracts 1 from the number every time. Right? And to show you how this probably could have been done as a loop instead, create another one, call it something different. Factorial 2. And we would do it as a loop. We'd simply do it as while number greater than 1. Go ahead and loop. And we're going to need a value to keep the return value, so we'll probably say that var ret val is equal to probably number minus 1. Because every time we want to multiply the number, say ret val is equal to plus equal number times, let's do this, minus number. I think that works. We might have an issue with should work. Okay, so this loop would probably do the same thing. Apply, we can look at it, still works. Now I could do this and say factorial 2, should work. Didn't. Hello, undefined. Oh, it's got to return the. Okay, so it's got to return the ret val as y. Not quite. Let's see. Actually, probably could be 0. Oh, I think we have to start with the highest, don't we? Yeah. Okay. So you can see that we can get exactly the same value with a loop. Recursive function calls and loops do exactly the same thing, essentially. Iteration explicitly uses repetition statement. Recursion achieves repetition through repeated function calls. They both involve a termination test. Iteration determines the loop continuation condition fails. Recursion determines when a base case has been recognized. Iteration, both with counter-controlled repetition and recursion, gradually approach termination. Iteration keeps modifying a counter until the counter assumes a value that makes the loop continuation fail. Recursion keeps producing simpler versions of the original problem where base case has been reached. Both iteration and recursion can occur infinitely. An infinite loop occurs with iteration if the loop never becomes false, and infinite recursion occurs when you never hit the base case. Any software problem that can be solved recursively can be solved with a loop, as I just showed you. A recursive approach is normally chosen in preference to an iterative approach when the recursive approach more naturally mirrors the problem and results in a program that's easier to understand and debug. Another reason to choose recursive solution is that an iterative solution may not be apparent. It may be more difficult. However, you really want to avoid using recursion in performance-critical situations, because recursive calls take time and consume additional memory. So, the problem with recursion is that every time it calls itself, it's actually got to branch to that memory location again, and it's got to use more memory off the heap and more memory and more memory. Loops are far more efficient in branching in memory and also memory usage than are recursion. So you always want to try and use a loop or iteration over recursion whenever you can. But that is what a recursive call is. It's a function that calls itself. That's all it basically is. Okay, questions? Questions about anything else? We're going to do a review of the midterm for the midterm. Oh, right. The midterm is on the 23rd, so we could. Let's see. Let's look at. Someone had a question. Was it Lab 3 or 4 that someone had a question on? I don't remember exactly. Someone said something about a question on the lab. Who was that? And I'll talk about the midterm. Lab 3. What's your question on Lab 3? Okay. Oh, the due date is, it looks like it's the 11th? Yes, it's the 11th. It's not the 29th. I had changed that. Sorry, I haven't updated this site yet. But it is the 11th, so this Thursday. And the other questions? As far as the midterm, I need to update this a little bit, actually. You guys, the midterm review is going to be very similar to this, but I have to update it because there's no HTML5 in this review. That's the old review, although it's going to be fairly similar to that. So, go ahead and you can look at that. And then next week, for sure, I will do a review on the midterm. That's going to be on the 23rd. Which link is JavaScript Loop 3? I'm not sure what you mean by that. 3. Oh, that's probably, might be this one, maybe? Yeah, because there's 2 of them, right? Pretty sure it's this one. Yeah, because the other Loop 3 would be this one, but that's different. Yeah, no. It's this one here. Definitely that one there. Any other questions? And the slides for tonight should be there. Oh, they're not. Okay, I'm sorry. Alright, I thought I uploaded them. Okay, yes, I will do that. Sorry about that. Thought I had uploaded them already, but let me see. Any other questions? Oh, I see. I did upload them, but I had the HTML lowercase instead of uppercase. Hold on for a second. Try it now. Yeah. I uploaded it with the wrong case. It should work now. Okay, question on lab 3. When I input 1 and 2, it somehow counts as bad input. I used for errors like 3, 4, and 5. I'd have to look at your code to see what's going on. If you can bring it to the lab on Thursday, that would be best. If not, you can email me it. Okay, Dennis, let me take a look. Any other questions?